This is Chapter 11, Part 7. A patient who weighs 55 kilograms is receiving a medication at the rate of 30 milliliters per hour. The concentration of the medication is 400 milligrams in 500 milliliters of dextrose solution. The recommended dose range for this drug is 2 to 5 micrograms per kilogram per minute. Is the patient receiving a safe dose? Okay. So what I need to figure out, first of all, is what is the minimum safe dose for someone who weighs 55 kilograms? And what is the maximum safe dose for someone who weighs 55 kilograms? And then if I can do that, then I can check to see if this, is safe, or if it's in the correct range. All right, so let's start off right here. I have 55 kilograms. I'm going to put this over 1. And I'm going to start off with the smallest safe dose, 2 micrograms per kilogram per minute. Okay? So here, the kilograms are going to cancel out, and I will have micrograms per minute. Okay? This up here, we're going to try to go to milliliters per hour. And then that way we can easily see if 30 is in the recommended range, okay? So milliliters, where else do I have? Okay, I have milligrams and milliliters right here. But these are milligrams, I have micrograms. So let's convert. There are 1,000 micrograms in 1 milligram. Okay, and my micrograms are going to cancel out here. Okay, so now I have milligrams per minute. All right, so let's use this, milligrams in milliliters. So I'm trying to get rid of milligrams. There are 400 milligrams in 500 milliliters. And now my milligrams are going to cancel out, which is good. And I have the milliliters I need. I just need an hour, and right now I have a minute. So there are 60 minutes in each hour. Okay? So the minute is going to cancel with the minutes here, and I will have milliliters per hour. Now I'm going to do exactly the same calculations with a 5 right here to find the maximum dose. Okay? So I'm just going to multiply straight across. 55 times 2 times 500 times 60 is a really big number. It's 3,300,000, and that's milliliters, over, I have 1,000 times 400, which is 400,000. One more zero, and that's hours. Now, obviously, we want to reduce this. Let's just cancel out some zeros so we can deal with smaller numbers. And I have 33 over 4, which is much nicer. 33 divided by 4 is 8.25 milliliters per hour. Okay, now this is the minimum safe dose. We want to find the maximum safe dose, and this is exactly the same, but a 5 is right there. So basically, I'm going to end up calculating 55 times 5 times 1 times 500 times 60 over 1 times 1,000 times 400 times 1. The only difference is that this is a 5 instead of a 2. All of our units are the same. They would all cancel out the same. So we can just save ourselves a little bit of time here. So 55 times 5 times 500 times 60. 825 with 4 zeros. So it's more than 8 million. And here we're multiplying the same thing, so this is still 400,000. And this is milliliters per hour. We can cross out some zeros. And we get 8 825 divided by 40, and I hit something wrong. 825 divided by 40 is 20.625 milliliters per hour. Okay, now what has been ordered? 30. 30 is not between 8.25 and 20.625, so this is not safe. You need to contact the prescriber. Okay, so let's look at the last problem, 1118. The order is Pitocin, and we've been told to start at 1 milliunit per minute, and then we get to increase it by 1 milliunit per minute every 15 minutes to a maximum of 10 milliunits. The IV strength is 10 milliunits per milliliter. Okay? So the first problem is to calculate the initial pump setting in milliliters per hour. Now, I know I didn't talk about this table. This table actually doesn't go along with anything in this little workbook. When I'm editing it, this is going to come out. All right, so we want to calculate the initial pump setting in milliliters per hour. We're supposed to start at 1 milliunit per minute. Okay, and then the pump, the strength is 10 milliunits per milliliter. Okay, so 10 milliunits per milliliter. Here, my milliunits are going to cancel out. So I have the milliliters on the top, which is good, but I want an hour, not a minute. So multiply by 60 minutes in 1 hour. And the minutes cancel. And you end up with 60 over 10, which is 6 milliliters per hour. Okay, so this is the initial. Okay, now what we can do is we can create what they call a titration table, which this is an example of. You have your initial rate, and then you get to increase it by a certain amount every time, and then you change your flow rate. You make that go up. Okay, so what we want to do first is we get to increase by 1 milliunit per minute every 15 minutes. Okay, so if you notice here on this example of a titration table that doesn't go with any problem, the flow rate goes up by the same amount every time. The difference between here and here is 1.5, here and here is 1.5, and so on. So if we can just calculate how much it's going to jump up every time, then the table is easy to fill out. We get to go up by 1 milliunit. Okay, well, our order is 1 milliunit per minute. Okay, and so what we want to figure out is we're supposed to do this. We want this in milliliters per hour. If we go up by 1, then what we get is exactly, look right here. If we're supposed to go in milliliters per hour and we get to increase by 1 every time, we actually have the same calculation we have here. Okay? If this we got to go up by 2 or 3 or 4 or whatever, it would be different. But this is exactly the same calculation. So there's really no reason, and we're supposed to go to the same unit. So there's really no reason to do another conversion. If this one, for example, got to go up by 2 every time, and so the jump was different. But here, what we're going to do is we end up with this titration table right here. Okay, our initial rate was 6 milliliters per hour. If we're going up by 1 every time, we said we actually end up going by the same as this, no calculation needed. So from here to here, after, when we jump up, we go to 12 and then 18, and we're going up by 6 every time. So if you're asked to fill out a titration table, this is what it's going to be. You figure out your initial dose, and then you figure out how much it's going to go up every time, depending on how much you get to administer every however long it is. And so that's how you do a titration table.